Hello, mathematicians. My name is Matt DiSorbo, covering the Algebra series for Skew the Script. In today's lesson, we'll be discussing functions and what makes a relationship a function or a non-function. Specifically, we'll be talking about this in the context of the Electoral College, the system we use to elect our nation's president. Without further ado, let's skew it. Welcome into lesson 1.1 of Skew the Script's Algebra series. Today we'll be discussing relationships and functions, specifically within the context of the Electoral College, the system we use to elect our nation's president. You can see here a map of the 50 states, the electoral votes assigned to each state labeled in. Naturally, this has been used for all presidential elections in recent memory. You need 270 electoral votes to win the presidency. You might recall in 2016, Donald Trump versus Hillary Clinton. Donald Trump won 46.1% of the popular vote. Hillary Clinton won 48.2%, more votes than Donald Trump, a higher percent of the popular vote. However, Donald Trump won more votes in the Electoral College, beating Hillary Clinton 306 to 232 and was elected president. How could this happen? Hillary Clinton won more votes, higher share of the popular vote, but Donald Trump won the presidency via the Electoral College. That's going to be the center of our key analysis today. Are electoral votes a function of people's, individual Americans' votes? If you'd like to follow along, check out the link below. Feel free to print or download the guided notes and work through them as we talk through the video. We'll be kicking off with a discussion of functions as maps. Here you see probably a familiar sight, a world map with the various countries, a pretty good map. And this here is a different kind of map. We have two columns, an X column and a Y column. Each row has various numbers. Specifically, a more succinct way to represent this function would be Y equals 2X. The reason why is because if we take each X term, multiply by 2, we get to the Y term. For example, -2 times 2 is -4, -1 times 2 is -2, and so on for the rest of the values. We can even plot this on the line. You can see each dot here represents one of the rows from our function table. And this map is actually defined as a function because each X is connected to exactly one Y. You can see here, each arrow is pointing to one Y value. Even this jumbled map is a function because even though the lines are crossing, each X is connected to exactly one Y. So now we can look at this table and ask the question, is this a function? And the answer is no. This map, this relationship is not a function because the X value, -3, is connected to Y equals 2 and Y equals 7. It's connected to two separate Y values. Let's think about this in the context of actual real life maps. So the map you see here is a good map. This is a map of New England, and each name is connected to exactly one place. It's very clear where Maine is. If I told you to go to Maine, you would know exactly where to go. However, this is a bad map. If I told you to go to Connecticut, what would you do? Where would you go? You'd probably be confused. You can see there are two separate spots labeled Connecticut on this map. This is the same idea with our function table. If you were given that X equals -3, you wouldn't know which Y to go to, 2 or -7. It's very confusing. Let's think about what we've already talked about, what makes a function. Let's think about what doesn't make a function, basically what a non-function or not a function is. Here are 3 examples of relationships, and we want to ask the question, are these functions? The first and the third are functions, while the second is not a function. One way we can check is by drawing a vertical line on these charts and checking if it intersects the relationship in more than one spot. In the second chart, you can see at X equals -4, the red line intersects the purple line twice, which makes this not a function. Now we can see why. If we look at the 2 points of the intersections, we have where X equals -4, Y equals 2, and -3. And again, remember, at this value, X equals -4, there's 2 possible Y values. This is a confusing map. It is not a function. In general, this is called the vertical line test. Very useful to show you if one X value maps to multiple Y values, AKA something is not a function. So our final review, this table on the left is a function. Each X connects to exactly one Y. Table on the right is not a function. We have multiple X values that connect to multiple Y values. So it is not a function. Here we have some extreme examples. On the left, each X value points to the same Y value, but that's okay because each X value has exactly one Y value. On the right, we have the opposite. The X value is 7 and it points to many different Y values. So on the left is okay, that is a function. On the right, that is very much not a function. Let's turn to our key example for today before we sort of run into our discussion. We'll be talking about the Electoral College as introduced at the start of the video. In the presidential election, candidates win electoral votes for winning states, and the way to win the presidency is to get 270 or more electoral votes. The state's number of electoral votes is equal to its number of senators, which is fixed at 2 per state, plus its number of House members, which is dependent on the size of the state. More populous states like California and Texas have more electoral votes because they have more House members in the House of Representatives. Whereas low population states, something like Vermont, get at least 3 electoral votes since they have the 2 fixed senators and 1 House of Representatives member. So our main question for today, is the number of electoral votes a function of people's votes, of individual Americans' votes? That's our key analysis for today. Let's look at a table of electoral versus individual people's votes. In 2016, we had Trump, who won 46% of the voter share and 304 electoral votes. He ended up winning the presidency. In 2016, as mentioned, Hillary Clinton won more votes, 48% of the votes, more votes than Trump did, but only 277 electoral votes, and lost the election. Whereas in 2008, John McCain won 46% of the vote and just 173 electoral votes and lost the election. However, you can see that both Trump and McCain had 46% of the voter share, but a different number of electoral votes. Therefore, electoral votes are not a function of people's votes. We have one X value mapping to multiple Y values. Candidates who won the same share of people's votes had very different outcomes. How could this be? That's kind of our question. And is this fair? Is the Electoral College system a fair system? So let's turn to our discussion for this topic. Let's consider these 3 states, relatively populous: California, Ohio, and Texas. California has 55 electoral votes, Ohio 18, and Texas 38. California is the largest with about 40 million people, then Texas 29 million, and finally Ohio with 12 million. This is all as of 2021. These examples are going to use hypothetical but demonstrative numbers, useful numbers of a situation that could actually occur. But again, hypothetical scenario. So let's say that California has mostly Democrats, 14 million Democrats to 10 million Republicans. Ohio also has 4 million Democrats to 3 million Republicans, whereas Texas has 10 million Republicans, so more Republicans to 7 million Democrats. If we add all these up for the individual states, we get the popular vote, 25 million Democrats, edging the 23 million Republicans in these 3 states. So in this case, in the popular vote, the Democrats would win. However, the Electoral College is not so simple. In the Electoral College, the winner takes all. So again, we can show you the vote totals for California, Ohio, and Texas. And in California, the Democrats would win. In Ohio, the Democrats would also win. And in Texas, the Republicans win, which means that the Democrat candidate gets all of California and Ohio's electoral votes. The Texas candidate, the Republican candidate, gets all of the 38 Texas votes. And you can see here, the Democrat will get 73 electoral votes. The Republican will get 38 of Texas votes. In this case, the Democrat wins in the electoral vote as well. So the electoral vote and the popular vote are a match in this case. So let's do it again, but with one very minor change. Specifically, let's take Texas, send 1 million Republicans to Ohio, and take Ohio and send 1 million Democrats to Texas. The population of both states do not change. We're just varying the composition of the individual states' voters just a bit. So we have our new setup here. Again, California, 14 to 10 in favor of Democrats. Ohio, 4 million to 3 million Republicans. Texas, 10 million to 7 million. This is our original setup. And now we can rotate, Texas gives 1 million Republicans to Ohio, Ohio 1 million Democrats to Texas. We flip-flop those, and now we see our new setup. In Texas, we have 9 million Republicans to 8 million Democrats. In Ohio, it's now 4 million Republicans to 3 million Democrats. The popular vote has not changed. Democrats still have the edge, 25 to 23 million. It's the same result as before. Since we just moved people around, we didn't add new Republicans or add new Democrats, we have the same popular vote. However, remember that the Electoral College is winner take all. And now if we look at the various states and the voter composition, we're going to see that the Republican will now win Ohio in addition to winning Texas. So if we add up the electoral votes, we see that the Republican has won 56 electoral votes to the Democrats' 55, meaning the Republican wins in the Electoral College. This clearly is a conflicting result. The electoral vote gives the victory to the Republican. The popular vote gives the victory to the Democrat. In this case, the candidate with fewer votes actually won the election. And I think what's important to highlight here is swinging these close states is key. We saw that California and Texas, California had far more Democrats than Republicans, Texas far more Republicans than Democrats, Ohio was very close. And swinging states like that is key to swinging the election. The bottom line here is winning more votes overall matters less than winning more votes in close states like Ohio, which are dubbed swing states. For example, John McCain in 2008, we've already referred to him. He won 46% of the vote, but lost handily to Obama in the Electoral College, earning just 173 electoral votes. Whereas Trump, with the same percent of the popular vote, 46%, actually won the Electoral College, 306 votes to 232, and was elected president despite having the same vote share as before. The reason why is because Trump flipped some key swing states, Wisconsin, Pennsylvania, Florida, and eventually was elected the president. So if we look at these electoral votes versus people's votes, again, we've seen the same voter share can lead to different electoral votes. The discussion question for you to work on with your classmates: should electoral votes be a function of people's votes or voter share? Justify your answer. That's all for today. We'll see you the next time on Skew the Script. Thanks again.